Good day, ladies and gentlemen. This short video is an attempt to explain some of the anomalous electron configurations that you could possibly come across. There are several elements whose electron configurations wouldn't be the same as we would predict when you actually measure them. So the two examples I'm going to show you are chromium and copper, although other elements do this. Silver is notable for this. Palladium, I think, does this. There's some other elements to do this. And I don't need you to know what all the exceptions are. I just want you to be able to explain why when you're confronted with them. When you take a look at chromium's electron configuration and you actually go out and attempt to do it, what you end up getting is something like this. Chromium has 24 electrons, and so the first 18 are taken up by argon, 19, 20, 24. This is what you would predict. This is what you would write. But when you actually measure chromium, what you actually get is this. And if you look at this, I think you can see what's happening. One of the s electrons has been taken to half fill the d orbitals. Copper does something very similar. So here's copper. This is what we would expect and predict for S2, 3d9, but that's not actually what it is when you measure it. When you measure it, you get this arrangement. And you can see an electron again has been stolen from the s orbitals to this time completely fill the d. So why does this happen? And this is the important part. Well, it turns out that half and fully filled d orbitals are lower energy than a half-filled s orbital. So when you have the fully filled d's, it's lower energy to have that s orbital half-filled and the d's fully filled, or the d's half-filled and the s orbitals half-filled. The actual ones are actually lower in energy than the other ones. That's how nature works. Nature tends towards lowest energy levels, and this is the basic explanation for why you would encounter these. If you have any questions, let me know. Thank you for your attention.